இல்ல பரவாயில்ல இருக்கட்டும்.
சரி, ஓகே.
உங்க ஜூம்
ஹலோ.
நீங்க ஸ்கிரீன்ஷாட் பண்ணுங்க.
ஓகே. ஆக்சுவலி நான் வந்து 2
இருக்காங்க. இன்னைக்கு Okay.
Good morning, everybody. So can you please confirm if you're able to see my screen and is my voice audible? Is my voice audible? Right. So let's give me a minute. All right. Okay. So today's agenda is going to be how to get placed in MAANG companies, right? So the root of everything to how to get placed in MAANG companies or actual software engineering is to understand what is the term engineering here. Okay. Could somebody tell me what is engineering? What is engineering? I think there is a delay here. Give me a minute. Okay. So what we can plan is after completing the session, we can have an FAQ session. Okay. Or a Q&A session where we can solve all your questions. Okay. Because we have a slight delay in the relay. There won't be any question answer session during the session. All right. Okay. So what is engineering? Let's see that. Engineering is actually invention. It's not just any kind of a regular invention, right? It is an approach to solve a real world problem. Right? Engineering means to solve a given problem in a specified approach, right? It's not, let's say that if somebody is asking you to solve a problem of addition of two numbers, okay, that anybody can write a code to solve the problem of addition of two numbers. But there are certain problems that are very much complicated that needs actual engineering. Okay. So let's say that I'm a BE graduate, right? So what I do after completing my engineering, I come out of the college and I say that I'm an engineer. But what engineering have I done in reality? Actually, I've done nothing, right? I just completed 4 years of engineering course and I call myself as an engineer. So let's say that after that I got placed in TCS, Infosys, CTS, in a software company, in a service-based company. And let's say that I've worked 1 year over there and I have acquired some coding knowledge. Can I still call myself as an engineer? Maybe people call you an engineer, but what is the designation there? People call you a technical analyst, right? Or a junior analyst, something like that. But actually, we haven't done any actual engineering. But if you take top five fortune companies like Meta, Apple, Facebook, Meta, Apple, Netflix, Google, right? These kind of companies, they give the designation as SDE1, SDE2, SDE3, and all. So what are that? What is the designation SDE? It's basically software developer or development engineer. But in so these are for the product based companies, like top 500 fortune companies. If you join a service based company, they call you a technical analyst. A few people might call you a software developer, but nobody calls you a software engineering developer or software developer engineer, right? Why? Because there is a huge difference between writing a regular code or just copying code from Google somewhere from Google and engineering your code. There's a huge difference. Okay. The question is why? Why can't a regular person coming out of a regular engineering college cannot become a software engineer? Why don't we call him a software engineer? Right? Let's take an example to identify what's the difference between a guy working in a product-based company, a top company, and a guy working in a regular engineering, coming out of a regular engineering college and joining um, a regular MNC, a service-based company, right? Now let's take examples of two people. Okay, let's say that there's a guy coming out of a regular engineering college. And there's a guy coming out from IIT. Okay. Now, why do I take this difference between these two guys? Because you know that all these top companies, right? Facebook, Google, Apple, Uber, Netflix, these guys take students from the reputed institutions like IIT, IIM, right? NITs. Why? Because their curriculum is so difficult that they are actually prepared to work for them. Let's take that I come out from a regular engineering college. My curriculum is very limited, right? There's something called data structures I study in CSE or IT, right? The data structure is just I can say only 5% of the entire data structure ocean. Okay. But the curriculum in IIT is actually totally different than what we can imagine. That is why they are actually prepared for these top companies, product based companies, right? Now let's see how they think in terms of coding, how they engineer their code. Okay, now let's say that we take an example of finding factors of a given number. Okay, let me just remove this for now. Okay, let's say that I'm going to find a factor of a given number. So basically, let's say that if somebody gives you a value 10, n equal to 10, what are the factors of 10? Say 1 into 10, 2 into 5, 5 into 2, and 10 into 1, right? So what are factors? Factors are numbers that are exactly divisible by a given number, okay, which does not give you a reminder. So 1 into 10 gives you the reminder 0, 2 into 5 gives you reminder 0, 5 into 2 gives you reminder 0, 10 into 1 gives you reminder 0. If you take 3, can I say 3 into 3.33333 equal to 10? It always has a reminder, right? It could be 0.000001. It always has a reminder. So 3 is not a factor of 10, right? So the factors of 10 are 1, 2, 5, and 10. These. So these are the factors of 10. Okay, good. Now let's take the factor of 24. We take the factor 24. It's actually 1 into 24, 2 into 12, 3 into 8, 4 into 6, 5 is not a factor, 6 into 4 again is 24, 7 is not a factor, 8 into 3, 9 is not a factor, 10 is not a factor, 11 is not a factor, and 12. 12 into 2 and 24 into 1. So how many factors do we have? Remove the duplicates now. So it's actually 4 here and 4 here, right? Just remove the duplicates. All the right hand sides are duplicates. Okay. So basically, I don't need this portion at all, right? I don't need this portion at all. I just take the left hand side. So basically, we have 8 numbers. So the factor of 10 is 4, and the factor of 24 is 8. Is that right? Okay. Now my question is, just give me a minute. Now my question is, can we do this for small numbers? Even if I give you n equal to 100, this can be calculated in just 1 minute. It's quite easy, right? What if I give you a very big number? You can actually calculate, but how long is it going to take for you? It might take 2 hours, 3 hours, 10 hours as well, right? Depending upon the number. All right. So if I add one extra zero, it is going to exponentially increase the time of evaluation. That is why we need computer programming. We depend on computers to solve a problem very quickly. And that is why we write code to solve the problem, right? Now let's say that I'm a regular engineering guy coming out of some regular local engineering college. Okay, I took, let's say that I took 95% in my engineering. I study very well. Okay, I came out. Somebody is giving me a problem of finding the factors of a given number. So I know the logic, right? So what I do, I write a code. Let me write a pseudo code for the count of n, right? So let's say that they've given me the challenge to find the factors of an n. So now I write a code for count of n. I just go inside. I say factors initially is zero factors initially for I equal to 1 to I less than or equal to n. I do if I modulus, if n modulus I is equal to 0, which means that it does not have a reminder. I'm doing a modular division. I just go inside, I say factor is equal to factors plus 1. Okay, every time I increment it. Otherwise, I don't increment. My for loop is actually over here. And I finally return the number of factors. So this is my pseudocode to find the factors of a given number. So if I give 10, the loop will start from 1 to 10. And every time I'll say n modulus 1, n modulus 2, n modulus 3. Whenever a specific I gives you a value 0 here, it means that's a factor. So I increment the factors count. That will give me the number of factors of a given number. Okay. Okay. So far so good. Now using this algorithm, let's try to solve a bigger number. And see what the actual problem we have. Now let's say that our computer is able to solve one. I take 8 zeros. Okay. Let me take 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Let's say that we have this number as n equal to this one. So this is how much? 1, 2, 3, 4, 5, 6, 7. So this is 100 million. Okay. This is actually 100 million. Okay. 10 crores basically. So this can be represented as 10 to the power of 8, right? Because we have 8 zeros, 10 to the power of 8. And let's assume that these many instructions take 1 second to process by our processor. It takes only 1 second. Okay. So could somebody tell me, if I add an extra 0 here, I'm going to add an extra 0. So actually that makes 10 to the power of 9, right? So how can we represent this? So how much extra seconds or how many extra minutes is going to take? I'll wait for you guys to respond. I won't answer from any of you. If 10 to the power of 8 takes 1 second, and if I'm going to add 1 0, that becomes 10 to the power of 9. What is the total processing time now? Safi said same 1 second. Nitish Babu said 10 seconds. Right, it's actually 10 seconds, right? How can we represent this one? This becomes 10 to the, okay. Before that, let's see the representations. Let's say that we have something called x to the power of m plus n. We can actually represent this as x to the power of m into x to the power of n, correct? Same way, can we just write this as 10 to the power of 8 into 10 to the power of 1? So what does this give us? 10 to the power of 8 is 1 second, and 10 to the power of 1 is what? 10. That's actually 10 seconds. Nitish is right. Okay, this is going to give you only. So this is 1 second, and 10 to the power of 9 is actually 10 seconds here. Right? Can you see the exponent increase? So what happens if I do? What happens if I have 10 to the power of 10? How many seconds? It's actually 10 to the power of 8 into 10 to the power of 2. So basically 1 into 100, that gives you 100 seconds. Right? Now let's take a very big number. Let's take 10 to the power of 18. Okay. See, we are comparing this with respect to our algorithm here. Okay. So let's say that this algorithm that we wrote takes 10 to the power of 8 seconds. I'm sorry, takes 1 second for this 100 million to solve. Then in that case, if we pass such a huge number like 10 to the power of 80 into it, it's going to take this much amount of time. Let's solve this. So it's going to be 10 to the power of 8 into 10 to the power of 10. Good. So what is this basically? This is 1 into 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So if we divide this, if we convert this seconds to, okay, let's take this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's convert this to hours. If you convert this to hours, it's actually 60 into 60, right? Convert this to hours, it's 60 into 60. And if you want to convert this to days into 24, and then if you want to convert this to years into 365. If you divide by this big number, the calculated value is approximately 317 years. Okay, this is the actual value. If we give such a big number, it will actually take 317 years to solve using this algorithm. Okay, now is it really viable to use this algorithm in this case? Is it really viable? Right? Nobody wants to wait 317 years just to see the output of your code. Right? Just to see the output of your code. And what if your output is wrong after 317 years? We won't even exist after 317 years. Maybe it will take a few generations, let's say 5, 6, 7 generations to see the output. And if the output is wrong, we have to rewrite our code and see. That's really not viable. Right? So coming out of a regular engineering college, if I'm going to solve a given problem without any optimization, without any observation, I'm going to write a piece of rubbish code, right? And now let's say that I got hired by Facebook. Facebook is giving me a problem similar to factors of a given number, and I only try to solve the problem for a very small input. Okay. And I write such a kind of code and put on the Facebook server. Millions of requests are coming in. Now that is going to crash Facebook, right? So I cannot use this algorithm. Now let's see how a person from IIT solves the problem. Okay. Now I am coming from IIT. I got only 60% because the curriculum is very tough. Now Facebook hired me, so he's asking me to solve the same problem, factors of a given number, right? Now let me see the observation. So what I do, immediately somebody gives me a problem, I don't start write code. Okay, what I do some observations first, right? Because what an engineer does, an engineer wants to find a solution to a given problem. So what the engineer does is he first observes the problem. He wants to understand what the problem is and then approach to a solution. Okay. Just give me a minute. Okay. So he wants to first observe the problem and then get some ideas on how to solve the problem, because he's going to invent a solution that is going to be useful for somebody, right? So what he does, he goes to the top here and sees and observes the issue. So he finds a pattern here. He finds that, okay, let me write it at the bottom again. For n equal to 10, he actually sees that 1 into 2, I'm sorry, 1 into 10, 2 into 5, 5 into 2, and 10 into 1. So he notices that the left hand side is always less than, let's say that this column is A. Let's say that this column is A and this column is B. Okay. So he notices that, yeah, actually if you see here, after which this is actually duplicate, right? So we have 1, 2, 5 and 10. So this part is duplicate. We don't need it. We don't need to count it. Correct. We have the 4 numbers in the top section itself. We have 1, 2, 5 and 10. So at this point, when the duplication starts at 5 into 2. So he's going to stop calculating it, right? He's going to stop calculating it. So here itself, he gets all 4 numbers, right? So what he sees here is, let's say that the left hand side is A and the right hand side is B. A and B. From here he notices that A is always less than or equal to B. Okay. He creates this expression. He understands it. Okay, I don't have to go from 1 to the end of the number. Rather, I can stop in between. So I need to find the limit where I need to stop my for loop. Okay. Okay. Now he's got something. He's got an idea by observing this pattern. The same goes for n equal to 24 as well. If you start writing factors, you can see that it actually starts duplicating at some point. Here it is. Till here it's 4, 6. From here, the duplication actually starts. Okay, 6 into 4, the duplication starts here. So even here, if you see, if left hand side is A and right hand side is B, A is always less than or equal to B, right? Okay. Now, if we say, what's actually B here? Let me look at the expression. Give me a minute. Okay. So just give me a second. Okay, so actually B equal to 6 divided by 24. 6 by 4 is 24. Right. So B equal to n by a. So can we also write this as, so if a is less than b, can we write b equal to n by a? Can we also write b equal to n by a? Will this work? Let's say that for 2, if we say 2 is less than or equal to 5 here, right? Can we also write this as 5 equal to 10 by 2? That's actually giving us an answer, right? This extraction. So here the value of a is 2, the value of a is 5. Can we write a is less than or equal to 5 divided by 10? Sorry, 10 divided by 2, where 10 is your n and a is your 2. Even this will give you same, right? It says 2 is less than or equal to 5. Even this representation, correct? Where a is equal to b becomes n by a, it gives the same expression, correct? So from this, can we also extract, see, for a loop to start, we need a starting point and an end point. A loop must start somewhere and it must end somewhere, right? Now the question is, what is the minimum value? What is the minimum value? Minimum value, we know that minimum value is always 1, correct? And what is the maximum value? Maximum value, we still don't know, correct? We're yet to find it, right? So from this expression, what we're trying to achieve, we can actually calculate the maximum value where the loop must actually stop, right? So now let's say that we have this expression. Let me take this. We have this expression, a is less than or equal to b, right? If we change b equal to n by a from the previous, this part, b also is also equal to n by a, right? We are actually finding what? We are actually finding the value, maximum value, right? So can we write a is less than or equal to n by a? This is also correct. Now let's take a to the left hand side. Now a square is less than or equal to n. If I want to move my square to the right hand side, it becomes a is less than or equal to square root of n, right? So from here, on the left hand side, I take the minimum values, and the right hand side, I have the maximum value, correct? So minimum value on the left hand side is 1, as we know, right? And the maximum value on the right hand side is 10. Right? So we've got the minimum value as well as the maximum value. So my maximum value is actually root 10. So I'm going to do this as root 10. Root 10 is my maximum value. So could somebody tell me, or let's say that n is 100. Instead of lighting the loop from 1 to 100, can I simply stop the loop from 1 to 10? Right? Doesn't that drastically decrease my execution time? If somebody is giving me 1000, what is square root of 1000? 100 into 100 is 10,000. Square root of 1000. I don't know. Let's take square root of 10,000. Square root of 10,000 is these two gone, which is actually, instead of running from 1 to 10,000 times, I only run the loop 100 times. So this is actually drastically reducing my execution time. So I have found this logic. With this, I can write a pseudocode again. I say, for count of n, just going inside, I say factor count is initially 0. Then I write my for loop for, let's keep it a and b now. For a equal to 1, 2, a less than or equal to square root of n. Say, one second. Say if n modulus A is equal to 0, in that case, I'm going to increment my count. I can do f equal to f plus 1 or simply f plus plus, which is a shorthand, right? And in some cases, I have to increment twice in case of perfect squares. So let's take that n equal to 100. So it's actually 1 into 10, 2 cross 50, and 3 is not a factor, 4 into 25, 5 into 20, then we have 10 into 10, and then we have 20 into 10, 20 into 20 star 5, and then 30, 40, no, 50 star 2, and 100 star 1. Okay, so if you see 1, 2, 3, 4, 5, 6, 7, 8, 8 counts. But here if you see, for this perfect square case, alone, I have just one number. I don't have a duplicate, right? In this case, what I can do, I need to modify my algorithm a little bit. So I just erase this. This is an edge case I need to handle, right? If A equal to n by A, only in that case I do f equal to f plus 2 else f plus plus, just increment 1. Then my for loop is gone, and I finally return my case, return my factors. So instead of running, this is the key here, instead of running from 1 to 10 to the power 18, you see what's going to happen now. I'm going to deduce the value. So let's say that 10 to the power of 18 is given to the guy who came out from IIT. He wrote this algorithm. According to his algorithm, 10 to the power of 18 is reduced to square root of 10 to the power of 18, right? If I want to remove this 10 square root from here, I need to do 10 to the power of 18 into what? 1 divided by 2. 2 cancels and this becomes 9. That actually gives the final result 10 to the power of 9. And what is 10 to the power of 9? 10 to the power of 8 into 10 to the power of 1, which is what? 1 into 10 seconds. That leaves you with just 10 seconds. Isn't this an engineered approach? Right? So basically, what are we doing? We are actually reducing the execution time from 317 years to just 10 seconds. How? With just small observations. Applying some small observation. Isn't this awesome? What do you guys think? All right, okay. So this is why data structures are needed, and this is why these top companies hire people from IIT, IIM and all, because instead of just start writing coding like this, right, without even thinking what the actual problem is, people write such kind of code. Facebook or Google, these huge companies doesn't want to invest in these guys because they can do code, but they are not engineered or optimized code. Why are they looking for optimized code? Let's look at it with an example. Let's say that, okay, Facebook says that, Meta says that WhatsApp actually deals with 100 billion messages per day. 100 billion messages per day. That includes your text, your audio, video, including audio and video calls. Okay, so if 100 billion messages are transferred over the WhatsApp servers, these messages needs to be processed. Correct? How are messages processed here? So now let's take an example of a processor. Let's say that you buy a computer that says 2.4 gigahertz of processor. What is gigahertz? Gigahertz is basically frequency or the cycles per second that your processor can process information. Or it's in simple terms, it's actually 2.4 into 2.4 into, let's convert this to megahertz into 1000. Let's convert this to kilohertz into 1000. Now let's convert it to bytes into 1000, and now convert it to bits into 8 bits. Finally 8 bits, right? So that's approximately 8 4 32, 16, 192, 192, 0, 0, 0, 0, 0, 0, and 0, 0, 0, which means your processor is capable of processing these many instructions per second in just 1 second. Okay. Now, how can we understand this properly? Let's take that user is going to type the alphabet A in the keyboard, a small a. This A has an ASCII value, ASCII, American standards for, it's something, I don't remember. Let's say that the ASCII value of A is actually 97. And the ASCII value of capital A is 65. Now let's say that the user actually types the alphabet A in the keyboard. So this has ASCII value A, and we all know that computers can only understand binary, zeros and ones. If you convert this to binary value, it's actually, let me just 1, 2, 4, 8, 16, 32, 64. So it's actually 1, 2, 3, 4, 5, 6, 7, 8, 128. So 8 bits, these are 8 different bits. 8 bits make 1 byte of data. So if you say I want to calculate 65, then can I simply do this? Put 1 here, all zeros, and 1 here. So when you convert a decimal number to a binary, this is how you do it. So basically the binary value of 65 is this: 1000001. 1000001 is the value. Now it actually has a 0 in front of it. That actually makes it 1 byte of data. Okay, 1 byte of data. If you just open your notepad and just type small a, save the file and see the file size. The file size will be 1 byte, because in binary this is the value 01000001. Okay, that makes it 1 byte. Now this 01000001 is passed to the RAM. RAM stores it, and from RAM an instruction is passed to your processor. Okay, now the processor takes this 01000001 and process it. Basically, for the processor has billions of transistors inside it, that those transistors need current to switch on and switch off. So in transistor, 0 means off state and 1 means on state. So if this pattern goes inside the processor, computer will now understand, okay, this user is trying to, it converts from binary to decimal. This user is trying to this binary, right? This pattern here gets converted to 65. Now 65 again goes back to the output unit through your motherboard, which is your monitor. In the monitor, the decimal will be converted to actual alphabet again. When this pattern goes inside the processor in binary, the processor will have this current on and off. Okay, so in this case, current off, current on, off, 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 and current on, which means that it is actually decimal value 65 corresponding to the alphabet uppercase A. And that is how you are able to see the value on your monitor when you type from your keyboard. Okay, so basically this is actually how many instructions? This is 8 instructions. But how many instructions can your processor handle? These many instructions: 192, 000, 000, and 000. That is why your processors are very fast. Okay, now let's take that. Now let's take this scenario for Facebook or WhatsApp. I'm sorry. 10 to the power of 100 billion is how much? 100 into 9 zeros, 1, 2, 3, 4, 5, 6. So that's actually 10 to the power of 11 instructions per day, right? So this is the thing. If a user writes a bad code, let's say that for one instruction to process one instruction or one message, okay, let's take this instruction as message here. So one instruction to process, it takes let's say hardly 1 second. Okay, one single computer will at least take 1 million, will take at least 1 million messages inside it. So it needs to process data very fast, right? So user here sends a message to the WhatsApp server. It again sends to the other user who are sending message to. Immediately you get the response from the user to WhatsApp. WhatsApp sends you a response saying that message is delivered. That is when you see double tick. So this needs to be very fast, be it video, audio, or text, or video call or audio call, whatever it is. It should be very, very fast. So if I write a bad code over there, and let's say that instead of 1 second, it takes, let's say 1 second, it takes 10 seconds. What happens? People will be frustrated and stop using WhatsApp itself. That is a very bad user experience, right? That is why they take the best of people. And who are the best of people? Frankly speaking, people coming out of IIT and IIMs and NITs, because their curriculum handles data structures. They know how to deal with, they have a lot of practical knowledge than theory, right? That is why a lot of people drop out of IIT, because they don't want to learn theory, they want to try and practice. Okay, so when people start practicing, right, they understand how to crack problems, how to build an engineered approach to a solution, right? Now we have touched the core and understood why these top companies hire these people rather than coming to regular engineering colleges, right? Now let's see what a data structure is. So we have 5-10 minutes left. We'll try to finish as soon as possible. DSA, that's data structures and algorithms. Okay, so data structures and algorithm deals with organizing your data in such a way that you can easily access them and easily store them in a given format, right? Let's say that if people are giving you fruits, 100 fruits, they are mixed in each other. Let's say that it has, in that 100 fruit, in that bag has 10 apples, 10 oranges, 10 grapes, and a lot of other fruits, right? And if somebody is asking you how many apples do you have, how can you count? You have to just put all the fruits out of the sack or out of the bag, and then you have to count it manually. That's going to be a difficult job. Rather, if somebody gives you a sack of fruits, you just put each fruit in a bucket. Let's say 10 apples, 10 oranges, 10 pineapples, right? If you segregate them, it will be easy for you to identify the count of each fruit, right? So a huge bag given to you. So there's a huge bag given to you, 100 fruits. You actually take them out and put in buckets. Each fruit goes into its own bucket, right? Then it will be easy for you to access. If somebody is asking you orange, you can directly pick up this orange bucket and give one to them. And the count is 9 here. You can easily track the count, right? So in data structures, for this purpose, you use something called as array. Array is one of the data structures, right? There are a lot of data structures. There is sorting, right? There is recursions, and then we have binary search, we have trees, we have hashing, we have maps. There are a lot of techniques that could be used to apply engineering in our code. If it's going to be very normal code, people don't care about the number of lines they write. It is not an optimized approach. That is not an engineered approach, right? In order to apply engineering in a code, you will have to use these kind of data structures. Only then your solution to the problem is actually engineered. Otherwise, it is not. So these things, what we see here, the data structures are actually in the curriculum of IIT and NITs. And that is why they are actually prepared for these top companies, right? So if you want to get placed in these kind of companies, if you're from a regular engineering college, or if you're coming from BSc or MCA, whatever your background is, if you know these data structures, it means you are eligible for top companies. You can apply there. You can get placed over there. People from MCA background, BSc background have been placed in Google, Facebook, and all, right? So it's just that you need to start learning data structures and algorithm. And how you implement that, there are a lot of websites, right? What I prefer is CodeChef. I solve problems here. We have Lead Code and we have HackerRank. There are a lot of sites, but these two are the top: CodeChef and Lead Code. You start learning algorithms and go solve the problem here. Okay, it'll be very interesting as well. So this is with the data structures, and then we have something called high-level design, or in short, we can say system design. System design is how you design your system, right? For example, let's say that Facebook initially had only one computer. When Mark Zuckerberg built Facebook, right? They didn't expect Facebook to be, sorry. Why? 1 minute. Give me a minute. I'm sorry. Okay. When Mark Zuckerberg built Facebook, he only had one computer. So initially there were just 100 requests coming per day. So Facebook, the computer was able to handle all the requests. And eventually someday it became 1,000, an extra zero here. Okay. That day what happened? The load on Facebook server became high, and someday an extra zero, it became 10,000 concurrent requests per day. So at that point, what happened? Facebook started to crash. The server crashed, it shut down. So Mark Zuckerberg, he actually came here, or Mark Zuckerberg, okay, starts the server manually. Okay. So what does he do? This became a problem. He don't know what to do. So what he did, he sat overnight and create something. There's something called memcached. Okay. Instead of picking the data from the server every time, it puts the data in the cache, and all the reused memory information will stay in the cache itself, so that the load on the server is very less. Everything will be taken from the cache. So Mark Zuckerberg took memcache and he modified the memcache program itself. So during the day, he will code and sleep in the night. His friend will stay awake in the night, and if the system crashes, he will restart the server. So that is how they manage Facebook. Then eventually what happened? They brought this concept of vertical scaling. What is vertical scaling? Let's say that Facebook initially had 1 GB of RAM. okay, and 100 GB of hard disk. They actually upgraded this to 4 GB RAM and 1 TB of hard disk. Okay, the same server is actually upgraded. This is called as vertical scaling. We call this as vertical scaling. Scaling your application like this. At some point, what happened? You cannot add more than 32 GB because your motherboard does not support more RAM slots. So there was a necessity to add a second computer. So the same thing goes here. Okay, this is server 1. This is server 2. And they had put a lot of servers. And let's say they have 10 servers. This is server number 10. What happens? The data, incoming data, right? This 10,000 requests or 100,000 requests that are coming in will be split among these. So what happens? Let's say that we have a lot of users like this. We have a lot of users. So let's say that we have 1 lakh users, 100,000 users. They're all trying to access Facebook. So before the server, there's something called a load balancer. Okay. So all 1 lakh go here and it gets split among these servers. The requests are split so that all 100,000 does not be processed by one server. Rather, it would be split between them. Jobs will split between them. And each of them will do their own job. So it's basically like round robin. Okay, let's say that we have 10 servers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If the request comes in, load balancer will pass the first request here and second request here, third here, fourth, fifth, sixth, 7, 8, 9, 10. And the forthcoming jobs will be put in the queue. So let's say that 3 has completed the processing. The 11th job will be sent to 3. So your load balancer does that job, right? And there are a lot of components involved, but this is the basic understanding. This is how huge companies handle their traffic. They implement data structures in their code. They have this high level system design to understand how the traffic comes into, how to solve the real world problems, right? So this is where you need to get started if you really want to get placed in MAANG type of companies, right? So I think we'll wrap up with the session and we'll start with the Q&A. If you guys have any questions, you can post this in the comments. I'll just answer them all. No questions? All right, then. If you guys don't have questions, I think we can wrap up with the session. The recordings will be made available to you. Okay. If someone memorizes all the codes from G, you can place in top companies, how he survived. You cannot memorize code, Arshad. You cannot memorize code. Memorizing code is very difficult. Even if you call an expert, ask him to solve a problem today, He'll write a set of lines of code. He cannot write the same lines of code tomorrow. There will be at least minor changes, but the concept or the approach is going to be the same. Janani, actually, this is a very generic question, right? Because the questions depends upon the companies. Okay, see, an experienced developer can easily crack TCS, CTS, all kinds of interviews. It's quite easy for them to crack. But the same person tries to attend interviews in Google, Facebook, it's actually a totally different world. The questions are not going to be the same, right? So it depends upon what kind of company you're going to get placed, and you based on your experience as well. Learn problem solving in code will help us land in MAANG. Of course. There's a guy called William Lin. Okay, this guy started coding at the age of 11, and during the age of 17, in just 7 years, he ranked number 17 in the world in CodeChef. His name is William Lin from Taiwan. This guy got an offer from MIT. He actually didn't give an entrance test. With just his world ranking, he was invited to, he was given an admission in MIT, Massachusetts. So that's the importance given to people, having high ranks in CodeChef and lead code. Of course, you can specify it. You will be given importance over there, because if you're able to solve problems, you have knowledge, deep knowledge in DSA, you will of course be given importance in the interviews. You'll have an upper hand there. See, the clearing in Google, clearing the first round itself is quite difficult. The first round itself will have problem solving. It's an online examination. You'll have to solve problems, or write your code and solve the problems. Only after that you will have a face-to-face interview. So you need to be very well prepared in data structures. You need to at least have 2-3 years experience in problem solving to crack their interviews. Feedback form, I think the organizers will share it in the WhatsApp group. Yes. Because there is a slight delay between my voice and your comments. Okay. So in case if I'm responding late, it means that I'm seeing your messages late. You can actually try Geeks for Cheeks. That is very good. They explain all kinds of data structures, and they also have sample problems to solve with explanations. Geeks for Geeks is the right place to start to learn there, but to practice problems, you still have to try CodeChef, Hacker Rank, Lead Code. Just a minute.